So calculating higher order derivatives. So far we've only done like the first derivative, but you can technically keep calculating derivatives on and forever. So just some notation. You see y prime is the first derivative, y double prime is the second derivative, y triple prime is the third derivative. To get the nth derivative, well, just to note, write that down, it'll be a y with a parentheses, whatever derivative they're asking you to find. The parentheses here is the key. Same thing here with the function here. F of parentheses n of x, like f prime to whatever derivative you want. Or if you write it like this, it'll be d, and you don't need a parentheses for this one, dn of y over dx of n. Just some notation there. So we're going to calculate a bunch of derivatives. So here we have f of x equals this whole thing. The first derivative, just take the derivative of each term. First derivative is 6x to the fifth minus 8x to the third plus, bring the 2 down, 10x minus 3. If you're confused with that one or need a refresher, pause and ask your teacher, but keep going. Bring the 5, 6 times 5 is 30, x to the fourth. Sorry, I keep making my 4's accidentally look like 9's. That's not a good habit. Minus 24, x squared plus 10. The third derivative is 120 x cubed minus 48x. And then you take the fourth derivative, it's 360 x squared minus 48. Nope, shouldn't be bad at all. This one here. Before you find the derivative, let's first rewrite it. Y is equal to x to the 1/2. And then we'll plus x to negative 2. You can leave that. So now we can apply the power rule. First derivative, 1/2 x to the 1/2 minus 1, which is 1 to the, negative 1/2, minus, bring the negative 2 down, negative 2, x to the negative 3. And then to find the second derivative, we can do the power rule again. 1/2 times negative 1/2 is negative 1/4 times x to the negative 1/2 minus 1, which is negative 3/2. This would be a plus because negative 2 times negative 3 is 6, x to the negative 4. All right, last example problem here. Find the second derivative with implicit differentiation. So first, let's just find the first derivative. So let's do cosine of y. Let's just do y prime to save some room. Cosine of y times y prime, since we're differentiating with respect to x, is equal to derivative of x, which is 1 plus y prime. So y prime, we'll bring all the y primes on one side. Cosine y times y prime minus y prime is equal to 1. Factor out the y prime, which is y prime times parentheses cosine of y minus 1 equals 1. And then y prime is equal to 1 over, divide both sides by cosine y minus 1, like that. So that's the first derivative. To get the second derivative, this might get a little ugly. There's a couple ways we can do this. The way I'm going to do it is just actually use the quotient rule. Low d high minus high d low over low low. So this is the here divided by here. So low d high, which is cosine y minus 1, multiplied by the derivative of the top, which is, just a 0, minus high d low minus 1 times the derivative of the bottom, which would be negative sine of y multiplied by y prime. And then over low low, which is cosine of y minus 1 squared. You see how this all cancels out because they're multiplying by 0? And then you see we have, let me just rewrite this first. -1 times negative sine y is a positive sine y multiplied by y prime over cosine of y minus 1 squared. So now like, oh, why is there a y prime? That's kind of weird. Well, maybe not too weird. But y prime you actually just plug in from right here. So you can rewrite this as, well, let's just leave the sine y over cosine of y minus 1 squared. And then we kind of multiply the y prime. And y prime is 1 over cosine y minus 1. Just like that. And this here is your final answer. If you did want to do another step to write it, since it's a cosine of y minus 1 squared times a 1 over cosine y minus 1, these terms are the same. So that's all the same as sine y over parentheses cosine y minus 1 cubed, because this is a squared and this is just a 1 exponent. You just add them together. So this here is your second derivative. You can go ahead and do the practice problems.